you find the limit using L'Hopital's rule of limit as x approaches 0 of cotangent of x minus 1 over x. So just a reminder, when typing things into the computer, be sure to use as many parentheses as you can to designate exactly what you mean and describe. It's okay. Here, I wrote out the three cases that it could possibly be pertaining to your question, but I'm not entirely clear on which one it is. So we'll just go through all three of these cases real fast, and hopefully you'll have your question answered because hopefully it falls into one of these three categories. Um, Case number one here, I have cotangent of x minus 1 divided by x. That's case number one here. Case number two for your question might be cotangent of x minus 1 divided by x. So that's case number two. And in case number three, cotangent of x minus 1 over x. And case number three is how a calculator would have read your question. Like if you type that into a calculator, this is how it would read it. Cotangent of x, then minus 1 over x being its own separate thing. So we'll just go through this and see which one is right for you. But before we do, let's remind ourselves quickly, what is L'Hopital's rule, right? I'm going to call that LHR for L'Hopital's rule. That's the abbreviation. What L'Hopital's rule says is if you have a function divided by another function and you try taking the limit as x approaches some value, we'll call that c, and you get an indeterminate form, then you can basically take the derivative of said function in the numerator and divide it by its derivative of the function in the denominator. Take that same exact limit, x approaches c, to the same value, and it'll actually be the same exact limit for this function here. But this only applies if you have an indeterminate form. And let's just go over what indeterminate forms are real quick. So indeterminate forms, IDF, okay? What is an indeterminate form? An indeterminate form is anything like if you had infinity divided by infinity after you plugged in that limit c. That's an indeterminate form. Vice versa, if you had like 0 over 0, that's also an indeterminate form. Negative infinity over infinity and infinity over negative infinity are also indeterminate forms. Another really good determinate form is infinity, plus or minus, it doesn't really matter, times 0 and vice versa. What does that equal? I have no idea. No one does. So if we ever ended up with any cases like this, we would know we have an indeterminate form. What's not an indeterminate form, but it's definitely a determinate form, DF, something you can determine, which often gets mistaken for an indeterminate form. A lot of students will like look at this and they will like, oh, this is indeterminate form. I gotta use L'Hopital's rule. But what's definitely in a determinate form is infinity over 0. That's okay. You can use that. Like if your limit becomes infinity over 0, then that's just fine, you can do that. Likewise, 0 over infinity, well, that's also fine as well, because we know what that is. We know what these evaluate into. The former evaluates into infinity here, and then 0 over infinity just goes to 0. That's like the ultimate form for those. So I bring that up because for two of these three cases, we actually do have determinate forms, and that means we don't need to apply L'Hopital's rule. And can you guess which ones they are? Well, let's just go through and just pop in our limit here for each of them. Let's just go through case by case. Um, so limit as x approaches 0, right? We'll do that for case one first. We'll say cotangent of 0, right, minus 1 over 0. Okay, so really quickly, cotangent, just make a little side note out here. Cotangent is, by definition, your cosine over your sine value, right? And so when you put a 0 in here, you get cosine of 0 over sine of 0, which equals 1 divided by 0, which is definitely a determinant form. Any finite number, I'm going to add this to the list here, any finite number divided by 0 does have a determinant form and it equals infinity. So 1 over 0 is infinity as you approach 0. So that being the case, coming back over here underneath our cotangent of 0 minus 1, we get an infinity for that cotangent of 0. We're subtracting 1, which is still infinity, and we're dividing by 0. Reducing that down, infinity minus 1 doesn't really make a dent in it, so it becomes infinity over 0. And what you see is that falls into the cases of determinant forms over here. It falls into that first little case, and that's the infinity over 0 case, which evaluates to just infinity. So you didn't even have to apply L'Hopital's rule to case 1. If your question was case 1, don't even bother using L'Hopital's rule. Just apply the limit, use a little trigonometry definition, and you'll find that that limit, as x approaches 0, the entire limit goes to infinity for case number 1. Case number 2 is very, very similar, okay? Do that. So for case number 2, I'll try and divide this up the screen. Okay, case number 2 is very, very similar. Once again, we're going to let limit as x approach 0. So that's going to give us a cotangent of 0 minus 1 divided by 0. Well, cotangent of 0 minus 1 is just cotangent of negative 1 over 0. Now, I don't know what cotangent of negative 1 is, but I definitely know that it comes to be a finite number. It might be a decimal number, an irrational number, but it's definitely a finite number here. Um, a tangible number divided by 0, which falls into this definite form case again. Any number divided by 0, or, as you approach 0, also becomes infinity again. So once again, in case number 2, we have infinity. So if your question was for case number 2, it also equals infinity, just like case number 1. Now, case number 3 is a little bit more complicated. It's actually a lot more complicated. I understated that. I really hope you're not talking about case number 3, because it's actually, you have to apply L'Hopital's rule not once, but like twice, and maybe even a third time. I kind of worked it out ahead of this video. It's definitely gonna take a lot of effort on our part. I'm gonna hope that you have either case 1 or case 2 and your question is answered. But if you do have case 3, please just, there's a area to specify in the comments. Please specify in the comments that you have case number 3, and I'll create a new video working specifically case number 3. But case 3 gets very, very arithmetically heavy and like mathy, and it involves like a L'Hopital's rule inside a L'Hopital's rule. I hope you don't have case number 3, but if you do, just let me know, and I will work a new video working case number 3. But I will warn you ahead of time, case number 3 is a little rigorous, but I will do my best to explain it and show the proper procedure to go through it. But it will take a whole video on its own. So yeah, thank you. I'm going to end the presentation now, and I hope my screen capture recorded all that because it didn't last time. All right, ciao.